Imagine something barely longer than the length of a sharpened pencil. You may not think something so tiny could hold the potential to unlock a map to the universe as we know it, but it turns out that sometimes the best things come in small packages. 21 centimeters has been coined the universe's magic length.
This is the length of the radio wavelength produced by neutral hydrogen at a frequency of roughly 1,420 MHz, poetically termed the 21 centimeter line. To understand how this phenomenon occurs and its potential implications in science, we must return to the particles that make up life's building blocks, protons and electrons. A hydrogen atom is composed of a single proton and electron. The atom possesses infinitely many energy levels, but the electron typically resides in the first energy level known as ground state. These basic energy levels make up the core structure of the atom. Now, if you were to delve deeper, you would reach the hyperfine structure, which refers to the minuscule energy splittings and shifts that occur between the nucleus and electrons. All particles possess an innate quantum characteristic known as spin. The particles are not literally spinning, rather it's a quantized property similar to mass or charge that the particle just has. Both the electron and proton possess a spin, and it can be categorized as either up or down. When both the proton and electron have the same spin, meaning both up or both down, they are parallel. When the particles flip from a parallel state to an anti-parallel state, a photon measuring exactly 21 centimeters in wavelength is emitted. While this hyperfine transition only occurs every 10 million years or so, its rarity is offset by the fact that hydrogen is the most abundant element in the universe. Neutral hydrogen can be found in hydrogen clouds, in and around galaxy clusters, and in regions of space where stars form. The 21 centimeter wavelength is affected by both the Doppler shift and the cosmological redshift. The Doppler shift means that the precise length of the wavelength is shifted depending on the motion of the hydrogen relative to Earth, whether it's moving away or towards Earth. The cosmological redshift causes the wavelength to be stretched due to the expansion of the universe itself, determined by the hydrogen's distance. Scientists can potentially use this data to map out the distribution of neutral hydrogen in the universe, as the 21 centimeter line can penetrate through the dust clouds while others obscure visible light. This frequency can be detected through the use of specific radio telescopes, and scientists can then map out galaxy spirals and structures, gain insight into our universe's dark ages, and locate both recent star formations and potentially engage the universe's history of star formations.
As scientists continue to study, detect, and measure the dispersion of neutral hydrogen in the universe, it's only a matter of time before the next breakthrough.